Hey everyone, so we're going to be looking at some enemy AI today. I'm going to be making some basic enemies and showing you how enemy AI works. And I'm also going to be showing you kind of how games in general work. So I'm going to start out showing you the basics of how coding a game works, because without knowing that, there's no way to really appreciate what goes into making enemy AI and making it so well done. And you might even appreciate some bigger games after hearing a little bit of this. So let's talk about AI for a minute, artificial intelligence in video games. Video games in general come down to two things. You have input, that's going to be anything the player does to interact with the environment, and then output, that's the response that the game gives back to you based on the input that you give it. So when we're creating an artificial intelligence, we have to basically consider any kind of input that can be given by the player and what kind of output you want to see in the game. So for something like a movie, you would have only output. You don't control what goes into it. For something like a board game, you would only have input. You don't have anything to control what comes out of it. It's only what you put in. So a video game has to consider both of those things. And the way it does that is it will take input from your keyboard or your gamepad, and it will use that input to decide what output it gives you. It will, if I press the jump button, my character will now jump. If I press the attack button, my character will now attack. So let's take a look at my car here. I'm going to click this, edit object. Right now I just have a little block of code. I've got a sprite that is just showing something to the player. It doesn't actually do anything in the game itself. But I've got some variables set up in here, and then every single frame, it's going to change what's going on. So a frame happens in my game is 60 times every single second. So when, for example, I want to move something, I will say I want to move my car, which currently has an x coordinate of 198 on this giant graph here. I want to move it from 198, I want to move that to, let's say, 194 this frame. So now it's moved to 194. Maybe I want to move that to 190. So now it moves again. So the normal move speed, I would say I want it to move 1 pixel every single frame. That's 60 times per second. So we'll go 1, 2, 3, 4, 5, 6, 7, all the way to 60 every single second. So 60 times a second, you're going to see some kind of animation there. That's how animation works in a video game. So if, for example, I wanted to hit the wall and bounce off, what I would do is I would say, okay, right now we are moving this 1 pixel every single frame. When it hits this wall, I want you to change that 1 pixel into a negative 1 pixel. So now it moves negative 1 pixel every single frame. Inside my car, you can see it's checking whether or not I'm pressing the enter button. And then if that's true, then the move car will equal true. It's checking if it hits the wall. If that's true, then it changes my direction to the negative my direction. So it's changing that 1 pixel per frame to a negative 1 pixel per frame. And then if move car is true, then we add my direction. So what this will do is when I press the enter button, it will then move the car to the left. And then once it hits the wall, it will then move the car to the right. So it's actually happening when an enemy is moving around in a game. It's doing a bunch of different checks to see where in a game it is. So you have to actually program in every single check. You have to check if they're next to a wall, if they're next to a short wall, a tall wall, if it's a short wall they can jump over, if it's a tall wall that they don't want to fall down, they want to move the opposite direction. Those are the different things you have to check, and so you get these big long blocks of code where you're checking all these different things, and that's how enemy AI works in a game. Alright, so now that that's out of the way, let's talk about some new stuff I did for the game. You have a bunch of enemy sprites that I've put in the game. These are obviously very temporary. They are not going to fit at all with the theme of Mistborn, but I have to have some animation sprites, something for jumping and moving and falling and attacking, and these custom sprites that I got off the internet have all of those animations that I need, so I can replace them with something particular to my game down the road when I want to add those in. I added some health to the enemies, just gave them a very basic amount of health so that you could draw a health bar for them, and then I put them in the game. I created a throwable coin. You can throw this coin at the enemy, and when it hits them, it removes their health a little bit. The health bar is working okay. The characters don't really do anything. They don't attack the player, but they can get hit by the coins, and that's what they need to do right now. I wasn't a huge fan of the way the coins look when you throw them. It looks like they're just kind of disappearing and appearing because it's moving so fast and drawing over that period of time. So I tried out a few different things to make it look right. The first thing I tried doing was making a for loop. It basically loops through over and over in a certain frame, and we tried to draw multiple coins in that so it would kind of create like a time-lapse effect, was sort of my thought when I was making it. It didn't end up looking quite right. It just looks like he's throwing a ton of coins all at once, so that's not really going to work. I thought maybe adding more coins would work, but it didn't look right either. I then tried using a sprite to show some kind of fade effect for the coin, and this actually looks a lot better in my opinion. Here you can see in slow motion what's actually happening. It starts to fade away as it goes through the frame, and I think that looks a lot better. Once I had my coin working the way I wanted it to, I went to work on the enemy some more. So I added in a few different states to the enemy. If you remember from one of my older videos, when you have a character like Mario, he'll be in different states. So for example, he might be running, or he might be walking, he might be jumping, or he might be swimming. And he's not doing all those things at the same time, and you don't want him to be. You don't want him to be doing a swimming animation and floating through the air when he's supposed to be jumping or running. So what this is doing is it's switching between all of these different states. So first he's jumping, then he's walking, then he's clinging. So you can see with our enemies, what we want them to do is we want them to have a wait state where they just sit around and do nothing. We want them to have a patrol state where they're walking around in a certain direction, not really with any intended purpose. And then eventually we're going to add in a few more states. We're going to add in states where they're, actively chasing the player, ones where they're attacking the player. But for right now, we're just going to leave it with a very basic wait and patrol state. I got the first step complete, which was just having them walk left and right. Every few seconds, they transition from a wait state to a patrol state and then back into their wait state. And every single time they move into patrol state, they choose a direction to walk. I had a difficult time initially getting the jump to work with the enemy, and I wanted him to jump every single time he got to a short wall, so he could properly chase after the player when it needs to happen. So at this point I just got him jumping on a timer. Every second or so he'll jump. Once that was working, I got to this giant block of code that I was most nervous about writing. It's the one that basically tries to figure out if the enemy is next to a short wall, if they're next to a tall wall, if they're next to a ledge that you don't want them to fall down, or one that you do want them to fall down based on how high the ledge is, and a bunch of different checks just to see what you need to do next. And this is run every single time they're switching from the patrol state to the wait state, and also every single time they're moving so they don't accidentally make a mistake that breaks the immersion. I ran into a lot of bugs when I was trying to get this to work. It's not worth talking about all of them, but eventually I did get the code working to bounce off the walls when they're in their patrol state. I wanted the enemies to jump when they hit a wall, so that was finally working here. Of course, he still flips directions, so I had to modify that, but it was working and that made me really happy. I wrote some code that worked that had them jump when they hit a short wall, and then they fell down when they got to the other side. I had a bunch of code that implemented the checks that I made before, mainly for the short walls, long drops, short drops, things like that, so that the character would behave normally when they got to these parts of the game. So now the enemy will jump at a short wall and turn around at a tall wall. I added some AI so that the enemy will not fall down when he's at a very tall ledge, but he'll turn around instead, and he'll also fall down normally on a short ledge. Well, that's about it for this episode. Again, if you want to play this game, you can find the link for the itch page in the description. You can play the Windows downloadable version. If you want to pre-test the game, play the pre-alpha version, you can join the Discord and we talk about bugs, and you can help me make the game really, really nice. If you want to see more updates, feel free to subscribe and like the video. Thanks so much for your time, and have a good Happy New Year.